Hi, everybody. Welcome to this talk. Too many ideas, too little data. Thanks to the organizers for having us, and thanks to you staying here.
The doors are closed now, so
it won't count. We would like to show you on how we overcome our cold start problem, and also show you some our first steps in the machine learning world on our journey. On our journey with machine learning. As you already guessed, I'm not an expert in presentation, so any technical faults may be excused. So why this talk? As I said before, we just wanted to show you what we are doing, and hopefully you can learn something, and hopefully we'll take a more successful first steps than we did. 58% of the data science or big data strategy projects fail, according to a Gartner surveys a year ago, by the end of last year. When I did my first project 4 years ago, a senior analyst or senior data mining specialist, it was called back then, told me that 80% of the projects failed. So obviously nothing much did there. When I was back then, I was thinking, I think I know what I'm doing, but now you can guess which was the first project that failed for me. However, it was called back then data mining, so that's not on my track record anymore as a data scientist. And I still think that data scientist projects fail more often than other software projects. I think the reasons for that are manifold. We just heard that the expectations are often simply too high. Totally agree with that. I don't think that's a coincidence that the newly released Amazon learning material starts with demystifying machine learning, deep learning, and AI. I also think it's often a problem of not having clear goals or a clear end goal, and I often think that data availability is a problem. That doesn't depend if you're a startup and starting on a green field, or if you're a huge corporation that has problems getting their data from mainframes or distribute their data between departments. And despite all these problems, machine learning and data science is still industries that are booming, and I think there are good reasons why this is the case, and a lot of good use cases to it, and success stories we've seen quite a lot today already. And I also hope that by the end of this talk, we could show you how we are tackling problems, how we at FreeU build data product and services, although little right now. And together we will push down the 58 to 50%. I skipped this one. So that we will do by identifying problems, check if machine learning helps us problems to solve it, by looking, collecting, analyzing our newfound data, monitoring models, and most importantly, to build usable solutions and make them better step by step. And we, of course, brought some examples, like I said. But who is telling you this? My name is Markus. I'm a data scientist at FreeU. I'm also a trained survey methodologist. Same buzzwords. I like statistics. Always did. In my free time, I like cycling and also visiting concerts. And I brought Thomas with me.
Yes. Hi, my name is Thomas. I'm also working at FreeU. I'm not a data scientist, but I'm a software engineer. I'm software architect, however you would call it. I'm tech loving. I love tech, and therefore I also interested in data science. Otherwise, you see, I'm doing in my free time, when I'm not coding, everything else, like kite surfing, basketball. I play for 20 years now, I think. This is what I do. But we are at FreeU. What do we do there? So we are an insurance company, or not really an insurance company, but a broker. But what is insurance about? If you take the definition of Wikipedia, it says very sober, insurance is a means of protection from financial loss. It is a form of risk management primarily used to hedge against the risk of a contingent or uncertain loss. So, in simple words, many people pay a small amount to hedge against the risk, but the risk has to be calculated by statistics so that you can say how much the amount the people have to pay and how much you can get when there's a claim. Yes, and the idea is very old. The Chinese did this also before Christus, but in the industry world, it's the idea of the sailors, and they spread their cargo on several ships so that when one ship sinks or gets fired or even the pirates came, not all their cargo is lost, but only a small amount of it. So they spread the risk so that he tells it's not true, but he has attacked the ship. Okay. I think yesterday in our dry run, we have seen that we will run out of time probably, so we skip this. Insurance, in principle, has three main pillars of which is built on. There's the risk management, there's the underwriting, and the claim processing. In the risk management, you calculate the risk, the premium which has to be paid to cover the risk. In the underwriting, you accept the risk and make the contract with the customers. In the claim processing, you pay the insured sum to the customer if the claim is correct. So this is all based on data. We will see that later. But it's not really in a free environment. It's very, very regulated. There are European regulations, European laws. There's an institution which take a look at the companies and also national law. But when you think of insurance, they have a lot of data, and as I told you, there is a lot of data involved because when you calculate the prices, there's, for instance, we have now one bike insurance where the bike is insured against theft. But what do we ask the customer? Where do you live? This is not perhaps the place where he locked his bike. When he commutes to the work, he locks it in the city at the train station, for instance. And how can you calculate the risk? We tackled this problem also by using IoT devices, and we come to this later. And in the talk before, in the keynote, also here, the profession. The statistics shows that civil servants are better, or not better driver, but they have less car accidents than other professions. But is it still so? Is it in the future also? Yeah, I think this is not the right thing how to insure risks. So our vision, we come from, or we are the digital daughter spin-off startup from a well-established insurance company. They say, okay, we cannot tackle these problems by ourselves, so we built up a new startup. Also, I think the talk in the morning was also about the 7 steps a business can do, and one thing was to build a startup. This talk was also very great, I think. So they have this huge tank ship which cannot move so fast, and they build sometimes the speedboat, but we are very modest people, so we want to build a spaceship, not a speedboat. Yeah, and now Markus comes here again.
Despite all the modesty, we are not here to tell you that machine learning or AI will solve all the problems in a moment. I guess the talk before told you about that before, that most people that say so will probably lie to you. However, there are dozens of use cases where machine learning models can assist us to make customers happy, our employees happy, by automating and helping with stuff. For example, take dynamic pricing, where you manage which risks to take depending on what you already have, or how to outbid your competitor. We can also, in the part of risk and price, talk about on-time insurance. Like we came from Cologne here, so if you think of Carnival, I think a lot of people would find that great to have an insurance just for Carnival. The exact product has to be defined yet, I guess, but still. There are also many organizational aspects where machine learning can help your insurance company. Like when it comes to fraud detection, it's already done, but it can be improved always. You can automate claim processes. You can automate underwriting stuff. And of course, marketing, it's the same as in other branches, in other industries. We have the same issues. We want to optimize our conversions, do predictive marketing, do satisfaction, and so on. And of course, IT systems.
Yeah, there are also many topics we could tackle with IT systems, not because we are an insurance company, but every company can this. It's like error prediction. You analyze your log streams and see, okay, when my system will fail. You can use it for scaling. Also, some recent research for development assistant, they are refactoring tools which are much better when they use, for instance, the analyze of tons of open source software, or even I seen one use case where they can predict the skeleton of a method when you create it. That's okay, out of my experience, I would suggest that the method would look this way. So there's also a lot of potential in there, but it's not this what we are tackling now because we want to deliver to the customer. Yes. So we promised examples. Now they came, or they will come. First of all, a very simple one, bike or not. When we started with our company, there was this user story, this idea of a hall of fame for customer bike pictures. Okay, we haven't built it, but the idea was there, so we tackled the problem at the beginning. When you have the chance, the customers, they can upload bike pictures. They can rate it, they can comment it, like on every social platform you are using now. But what about pictures, perhaps, which are inappropriate, or where you have personal rights you have to consider? Or even if they are pictures against the law, which you cannot openly make open accessible. So, how to deal with it? We said, okay, image recognition would be a great solution for that, and we looked at the market and say, okay, is it already solved? Is it accessible? Is it affordable? I think so, yes. So we runs on AWS, so where's my pointer? To start the video. We built in the AWS recognition service, but Google and Azure has similar ones. Oh, it's not playing. No. So when you want to upload a bike picture, I take a cat. Everybody loves cats. When you upload it, we send it to the recognition service. We get back the labels. Yeah, the internet connection was very slow. It was in the office. At home it's much better, but okay. After a while, we say, okay, we don't accept the bike. So when you continue with that, this was the labels which comes from the recognition server for the cat. Okay, it's very confident that that's a cat, it's a mammal, okay, panther, I don't know. But, okay, when we now want to upload a picture of a bike, yes, there's a bike, 99%, but there's also a human, so we would reject that also because of personal rights. This was how we tackled this problem, and it was very, I think it was done in one sprint as a feature, and not as the main feature, but as part of one story, so it was easily integrated. A more sophisticated example now from Markus.
Yeah, I'm not sure about that. But it still was a problem for us that we cannot insure carbon bikes at the moment. So carbon bikes, if you are road bike enthusiast like I am, I know that when you crash with a carbon bike, you have to X-ray the frame, and
it's expensive.
Yeah, we don't want to do that.
And our risk carrier don't want it either.
Yeah. So right now we have no solution, but have to decline anybody that wants to insure the carbon bike. Well, that sounded negative. However, we wanted to make the process as painless as possible for our customers. So if it happens, We wrote it on the website before, and still I don't like reading text, to be honest. A lot of our customers did, or a lot is probably a lot, but some of our customers did not as me. So they insured their carbon bikes. And we were thinking that maybe a solution can be, if it's not enough to write it on the website, to build a classifier with at least an accuracy of 80%. So we started by scraping the web until we had about 1,500 bikes after data cleaning. And short remark here, scrape responsible. Don't attack the website, check the robots.txt and read the terms of use. Don't want to get into legal trouble there. We also then, after collecting the data, wrangled a bit with it. So feature engineering here is pretty simple. We just attract the price, the brand, and the model of the bike, also the type. Model is dependent. Right now it's out of scope because we wanted to keep it as easy, and you see it's very easy right now. Our model is not only one tree, but many. So we use the random forest model that is not prone to overfit, even on smaller data like we had, and achieved, after some tuning, an accuracy of over 88%. What I also especially like about random forest is that it's not a black box. So we do know our weaknesses, namely it's carbon e-bikes and steel road bikes, which are both high price. E-bikes are usually not made from carbon, but aluminum, and steel and road bikes expensive are most certainly carbon. We generated a report on our database and found out that there are some bikes that are carbon that we had in the office, and thought, well, how to prevent it? We can deploy a model. Here we deployed it as a serverless function on AWS and also monitor the deployment. So with tracking, we see that conversion rates are not dropping, and we only had one carbon bike, I guess, since again, a short video how that looks.
So we insure here an expensive bike.
Yeah.
5,000 euros.
The offer. And after you enter the type of the bike and the manufacturer of the bike, we send it with the price to our serverless function. And here you can see it was quite quick. You have already seen the yellow text. And at the end of the video, there will be a pop-up as well.
Yes, if you don't read the text, we present a pop-up and let the customer confirm, okay, he is sure that it's not a carbon bike.
Which the best way is probably A/B test will show.
Yes. UX is not finished.
What I especially like about this project is that it shows that machine learning can alter existing processes. I mean, we could have hard-coded a lot of if-else conditions, but that doesn't make any fun, at least for me. Machine learning projects also do not have to be like this huge projects with 100,000 euros budget, but also can have value little by little. And additionally, we add bike data to our data lake. That's not what I wanted to see. Yeah, you can see what goes in the model and what comes out. So basically JSON, yeah.
Yes. Next thing would be fraud. As I already mentioned, we cooperate with another company. They build small IT devices which can be mounted on the bike. It's at two purposes. One is alarm system, so the bike is locked and is activated the device, and when it's now moved, then a loud alarm ring is can be heard or is triggered by the device. The other thing is that it sends us data. So every time the device is moved, when it's activated, then we the cooperation partner sends us via webhook data. We store it in our database, and when now the we can provide it to our clerks in the dashboard, so that you can see where the alarm is activated. So when we now have a fraud a claim report, so the customer says, I comes to my bike in where I locked it and it was gone in the morning. It was on this date and my contract number is this. Then we can check our webhook data. We can see what device data we get from the company, and okay, this is the contract. It is. We can check this location of the alarm. We can see he said it was in front of my home. We can check it with the customer address, and today it's the protein calculator, the head of one of our employee, but you can guess that this can also be very easily automated. For instance, for first indication, so you can here very quickly set it's fraud or it's not fraud.
Yeah. What it also shows is that IoT devices and data collected by IoT have a lot of great potential, in my opinion. I mean, it's a killer feature in your model, so it's probably the most important one if you give it to your model. Another example would be, think of skiers that are connected to your device, and if your skiing is getting worse in the afternoon, maybe you had something to drink over the afternoon break, you get a push notification when we analyzed your swings, and it says, hey, take a break, your next coffee is on us, don't crash, we don't want to pay your hospital bills. Coffee is easier for us.
So it's a win-win.
Yeah. This is all prevention instead of paying claims. So we're doing the same for bicycles, or we are working on it, to be honest. That's very hypothetical right now and work in progress, not end to end. But the problem is that we want to assess accident risk and the risk of theft based on the location that the IoT device sends us. So to do so, we use OpenStreetMap, open data from the Unfallschadenatlas, it's called in Germany, and as well as data on bicycle thefts, which is available in small inquiries to the parliament. So welcome to getting data out of PDF coding hell. And yeah, the approach is, I like the approach because it's combining the strength of traditional statistics when calculating the accident risk as well as deep learning, because when we collect the model, we collect image tiles. So basically it's two approaches. I won't delve too much into, but we take an image tile, store it in a PostGIS database, which is an extension to your PostgreSQL database, and create location embeddings via triplet loss networks. You probably do know the example of the man, king, women, queen example. It's the same for taking location and snippets out of maps. And we can also take these snippets and calculate accident theft risk based on what the surrounding environment is. Like if there is a bar or a pub, the risk of vandalism is probably higher than if it's a
living area or something like that.
Living area, yeah. That's right. Just to give you an idea how the data looks, you can see here on the right it's Mannheim, Germany, and all these points are accidents. On the left you see features that can be engineered from OpenStreet data, like if there are tram tracks, if there is a shopping center in proximity. And if you have a look here at the map, this is a shopping map, and it's a really dangerous area for cycling. So yeah, it's something. But before you all leave the room, some already did, I'm sorry about that. And I delved too deeply in technical terms. Let us focus on some team and project organization stuff to help you overcome the cold start problem. At the beginning of our machine learning data science journey, when I started, when I started was already the AWS implemented. We faced challenges. For us, they were of organizational nature, the difficult structuring of data science projects, the right techniques and tools to use. And let's start with the team organization. I think it's very important that data science, former colleagues of mine would probably call that hygiene factors. I'm not sure if that translates very good to English. As you have to make sure that top management is behind your project. So, and that experimentation is also encouraged, because we've heard it before, we all know it, projects will fail, and it's often easier to communicate that your project just failed when you have the back. Also, it's important, in my opinion, even more important, to keep focused on the business objective, which can be really hard. I mean, take me for an example. Instead of doing something useful the last weekends, writing my master thesis or so, I spent the time learning about generative adversarial networks. So, yeah, one other part of why it's so great. It's also very important that the data scientist does not sit in a silo, or ideally within the IT team, because data scientists often only have a limited understanding, or when I think of me, have only a limited understanding of good software engineering. It gets better, and especially when it comes to deploying, testing. Don't start with DevOps data science, which is very hard, I guess. I think. So we can learn a lot from software engineers, and I think we already heard it in the talk before. Skills are critical issues. So
yes, and also if you see in the last years, there's this DevOps obstacle which should be removed, and is removed right now more and more. This is also for data science. I think this is a skill which, when you want to build data-driven services, has to be integrated in the team. And for 10 years ago, we throw our application over the wall and say, okay, the ops guys will run it. And I think this is not the right approach, and it's with data science the same. So if Markus models a model and provide us a service, then we as a team has to run it and integrate it. Yeah.
Of course, there are also some technical requirements so that data science can be effective. In my opinion, it's that there is a stable, reliable, and accessible infrastructure before you're hiring your first data scientist. I mean, data analysts as well as scientists need access to database, and also have a need for documentation. If you do not provide that, in my opinion, you won't get any success in your data products. And especially in my experience in big companies, it was hard to get this information sometimes. And also, if I could write a wish list, there's also a great need that there is data can be loaded and transformed quickly, also the raw data, not only metrics. Predictions and modeling results should be easily automated. Have a look at the stuff Stitch Fix does in that area. They are great, enabling full stack data science. It's very impressive, in my opinion. The same goes for KPIs and predictions. Do make them available so that everybody can see whether your model has success or is failing. And better than I could that, from a data engineering perspective, describe that Monica Rogati in a HackerNoon article, the AI hierarchy of needs, where she describes each of these steps. So first start by collecting the data, then find a way to move, store your data, explore and transform them. Before you start at the beginning of the top with AI and deep learning, make sure you get the basics right. It's simply, I think it's the same everywhere, if it's machine learning or not. So after you made sure that the prerequisites are fulfilled to any degree, I think it's important, and it was important for me to structure my data problems, because I often had the problem that I was doing a lot, but it was not very goal-oriented. So what really helped me was to structure the problem in 4 more or less easy questions. So the first one, we as a team ask ourselves, can the problem be solved with machine learning? I said the team, that's quite important and maybe worth a notice. I hope that everybody in our small team, we are 12 people at the moment, 13, 12,
13, yeah.
It doesn't matter, knows about clustering regression, because we have a talk in the onboarding week that is says demystifying data science, AI, machine learning, deep learning, all the stuff, so that they get an idea and that they can classify a problem.
Yeah, also that there's an awareness, so that, for instance, the carbon check in the old company, in the enterprise company, there would be a task force from 5 people, and they look at each contract and say it's a carbon bike or not. You can do this, but you can also automate it.
The next question we often ask is whether we have to deploy a machine learning or train a machine learning model, because I think a lot of the use cases for machine learning can be solved via thorough analysis of your data you already collected. The next, of course, is very important because it's whether data is available or not and whether data can be acquired. And at last, and most difficult here, to ask yourself, is the problem relevant to your business? But most of you will probably work in an agile way, I think, from a software perspective. And in my experience, working with Scrum can also be very difficult in data science area. Estimating how many story points your model training is taking is a very difficult task, at least it was for me. So what helped me was deploying the OKR principles, its objectives and key results. And if I find the mouse cursor.
Can use the arrows. Yeah.
Oops. Sorry about that. It's just it's defining an objective. At the example of the carbon check, it would be detect whether a bike is carbon or not, and key results. And key results would be collect 1,000 data points till the end of next week. Another key result would be document your pre-processing steps so it can be recreated by others. The next key step would be to say, okay, I want a model that has a precision of 80%. And so it's easy. You can tick the boxes. Did I do that? Yes or no? And then you can work on it. It's also important to keep in mind what tools and techniques you have, especially when it comes to limited data. Because now you know your problem, you have an idea how to solve it, your research question is formulated and can be tested. After all, it's called data science, so there has to be a little science part in it. And it might very well be the case that an RP is already available that solves your problem. AWS has recognition, has Lex, comprehend. Now since last week, 2 weeks ago, it also has forecast, where you load your data in S3 and get a forecast. Google, Azure, they all have probably the same services. But what if your problem cannot be solved by the tools from the shelf? Your next step is probably ask yourself, which data do you need? Can the data you have be used to answer your question? Or do you have the means to collect new data? And this is then it comes to data gathering, so how to get data, and there are great tools, for example, for scraping. There's, if you work with images, the FATCoon batch add-on, it's called. It's you just say, yes, I want to scrape this site, and it selects every image. You can also check whether the image is copyrighted or not, so there's no legal issue there. And of course, selector gadget, if you know that, just select selector gadget, and it's based on the diff, is it called diff class in CSS? Yeah. You can select content from the website. There are also available data sets you can use. Take ImageNet, for example. If you work with images, you can use the Google dataset search. That is fairly new, I think 2 months. They started with a beta version, or even iterate first ideas on your Kaggle dataset. And of course, there's open data. You've seen, we also used weather, open weather data. We used maps. We used the small inquiries. Data is there if you look for it, in my opinion. Yes. And even if it's not the vast amount, you probably will spend quite some time labeling it. So you can use it.
For instance, one short story when we were in a workshop, and there was the idea of making a city secure for bikes. We said, okay, how do we get the data for thefts, for instance? And we 10-minute brainstorming and said, okay, how we can, we ask the customer, we ask newspapers or something like that. And then somebody typed in a Google search and we saw there was a small inquiry with all the data we needed. So sometimes it's worth to look at it and don't make it too complicated.
And if you decide to work with images, there are of course augmentation strategies like rotating, scaling, cropping, or adding Gaussian noise to it. A bit more advanced, use generative adversarial networks to create more training data. Not so good for text data, but there are strategies like you could shuffle within. You can use back translation, so sending your text to Google Translate, getting it back. There are some words changed. You can use synonyms, which is pretty much the same, and you can also randomly change or delete a letter in a word to make it more robust. However, fair warning, if you augment your data, it's often the case that it detects the cases you augmented for pretty good. The cases you did not augment for, it will most certainly fail to detect. So yeah, be cautious with it. When it comes to modeling, there's some simple principles like making sure to use cross-validation instead of an 80-20 test train split. And I'm getting too technical again. So last remark, if you use deep learning, check transfer learning strategies and also the pre-trained model. TensorFlow Hub gives you a great overview and a great starting point for your journey with deep learning if you want to take this one. Yeah.
Yes. Now we come back to a more business perspective, and I'm very surprised that we are faster when we do this now and then in the dry run, but okay, no problem. When we started to build the first product, Markus was not on board, so we built the product more traditional in an agile way. We go for the MVP, the minimal viable product. So we have an idea and we build a prototype, and then we have an experiment. From the experiment, we measure the data, and with the data, we learn. And this is how we build the product and improve the product. And this can also be adapted to machine learning solutions, products, models, and everything, as we told before. For instance, the random forest for the carbon check was the idea. We don't want to do it manually. We don't want to do it in a if-else construct and check for all rules. The rule-based approach, like an SAP talk before. We want to do it in a machine learning way. And so we make this very small experiment. We measure the data, we learn, and this gives us a possibility to pivot or steer very quickly. So we can change and adapt our process of developing the product very fast. And this is normally in the lean startup way, like from Eric Rice or Stephen Blank, like they suggested, and we want to build also the products which are data-driven also by this way. So again, when you think about MVPs, there are a lot of confusion. When I experienced it, this is not an MVP. It's not like you want to have a car in the end and you start with a tire, then the chassis, then the body, and then it's a car. Because you cannot sell the tire as a car to the customer. So this is not what we do, or what you should do. It's an increment and not a product. Now we can say, okay, I build it differently. I build a kickboard, then I build a bicycle, then I build a motorcycle, and then I have a car. The good thing about that is, yes, you can move directly with the first iteration, but you change the purpose of it. So it's not that what you want to do. So it's a vehicle in every time, but it's not the car in the end at the beginning. I hope it's clear. So what you really want to do is you build a crap car and improve it over the time, so that at the end it's I don't know, a Mercedes like the taxi we drove in the morning or something like that, but you can at any time stop the evaluation and say, okay, this is good enough for me now. This is not possible with the other approach. So for instance, the random forest is perhaps a 1 to 2 on this picture, but it's sufficient for our purpose now, and we can say, okay, we don't put more effort in it, except the data we measure, the tracking and the things we check how many cases we have with it, shows us that it's worth to put more energy in it. So it's, yeah, this, hopefully it's clear what I meant. Yeah, improve our product service when it's necessary. This is another, I think, very good distinction, how you can see it. What you don't want to do is build the whole thing in one dimension, but you want to build every dimension a little bit. It's like the other picture, but I think it's made more clear in a business thing. So what you don't want to do is, for instance, in the first model, put too much feature in it. And feature is a funny thing. It's a feature in software engineering and also in the model. So don't put too many features in it. And don't change the purpose of the app, of your software, or also of your model. Yeah. And that's it. Thank you for your attention. The takeaways of this talk would be: build something that helps people. Don't do this because you have a great idea and want to deal with technique or something like that. This you can do in a free time, but not as a business product. Structure your data problem. I attend the ML conference in May, and I think there was one quote it was very good. There was a data scientist who said that he spent the time analyzing the data. In university, it was 5% and 95% on the algorithm. And in the business, he said, I spent 95% on data analysis and 5% of the algorithm. I think that is very funny. So structure the data. You have to know your data. You have to know what the problem domain is and how the data is related to your domain. Also very important, I think, check if the problem is already solved and available as an affordable service. So you won't win a prize if you make another image recognition. You cannot build it better as it is already there, and it's very cheap. We don't pay you $1 for a month for the service with this amount of calls we do now. Also, Markus said, embed data science and machine learning in an effective way in an organization. It makes no sense that there's a silo or a prison where he's in there and he has to be in the team and has make the team aware of what he's capable to do. And the team thinks in a different way when he knows what is possible. And this, I think, leads to better products. And the last one is build end-to-end. Build something the customer is involved in. Customer is not the right word, the person. If we build a product for our employees, it's also a customer of the service. But the customer of the service has to be directly involved and has the benefit of using the service. Yes, that's it. Thank you.
Thank you.